Hey everybody, it's Jeff, and we're doing something a little different. Today I'm working on some Go, this project called COM. It's a component framework, which I'll explain in a bit for Go, but this stream, I actually have a friend of mine joining me. Actually, you could probably just see his cursor.
Woo!
Is a friend of mine named Steve, and he's relatively new to Go. I think you just started learning within the last few months, right?
Yeah, probably the last 6 months, and then I've been using it sort of as my daily driver, so to speak, for probably 3 months.
You've been doing like audio stuff recently, right?
Yeah. I've been doing a lot of web app stuff, but specifically, I'm trying to sort of expand the sort of audio ecosystem a little bit. So I've built EQs and compressors and Go and stuff like that. So.
Which is really cool. I kind of want to try some of that stuff at some point. Steve and I have worked together on a lot of audio stuff previously. Actually helped produce part of my album that's still in production. But today we're working on Go stuff. So this project isn't really complete. It's not really well documented or anything like that, and it says it's basically 17 days old. It's actually based on an older version of the framework that is a little bit older, about a year older, and we use this for Command IO, and I've been using it for pretty much everything else that I've been making. And then it's based on a bunch of ideas that are like at least a decade old, but this sort of iteration, there were some problems with this version, so this iteration was trying to fix some of those. One of the big ones was testability, as well as simplifying some of the boilerplate in the general API. And I've mentioned this before in a previous stream. I kind of showed we use this in the SSH JQ as a service project, and so I introduced this to Steve the other day, and it sounds like you get it. Like, it's kind of a very kind of abstract, simple thing, so it's probably hard for people to wrap their heads around. I thought maybe we could kind of do a quick example with it
Sure.
to get a better feel for it. And then the main thing that I wanted to do today was actually, which shouldn't take that long, is integrate Go plugins. So this is basically dynamic libraries for Go. So you can actually, I think 1.8 introduced this ability to build a project in plugin mode, which basically creates a shared object binary. And then another project, your application, can load, basically open that binary and then look up symbols and then use them. So it's a great way to package up extra functions, extra objects, or whatever. And so that is kind of a minimal bit of functionality. Once you have the thing you're looking up symbols, like how do you organize the code in there to integrate with your application code? And so COM actually solves that. And so these things actually are kind of made for each other. And so I wanted to build a plugins component for this framework so that you could create new components as plugins. And then you can build apps where people can drop in precompiled plugins or extensions without having to recompile. So some code. Did you look at the code much? I think you did, right?
I did, yeah.
So it might not have been. I don't know how obvious it is. Also because I haven't gotten to documenting any much of this, and a lot of the code in the main com thing is a lot of reflection stuff, and so it's very sort of like it's very much like an implementation. It doesn't really communicate how you would use it very well.
Speaking of the reflection stuff,
Mm-hmm.
I found this. Oh, I'm in your screen. Let me pull up my chat window. There we go. There's a really great sort of blog post.
You could just open my
Okay.
Chrome and
Yeah, I think that's the way to do this. Okay. So, Chrome. This. Oh, okay. I can't paste, but there's a
no,
really
it
great.
pasted. Oh, it
I'm
pasted
trying to
mine. Oh,
paste.
I see. I see. I see.
Yeah.
Oh, that's funny. I think there's an option. So we're using Screen Hero, and there's actually I think an option that lets you do that kind of stuff.
Yeah. Let me turn that on real quick.
But yeah, what was the question? Or
So there's this really great blog post. I think it's called "The Laws of Reflection." It's
oh,
inside the Go doc for Reflect, and it's a really great sort of like breakdown of all the reflection stuff.
ooh, this is not Go specific. Um, yeah, I use and actually usually in earlier iterations of this, use reflection quite a bit.
There you go. That
Yeah,
one.
that first one. And yeah, great way to understand that. Like for a compiled language, it's actually pretty nice to have this level of reflection built in. It
Mm-hmm.
allows you to do a lot of dynamic stuff. And Go has a lot of properties that makes it kind of feel like a dynamic language, and yet it's not. So,
Mm-hmm.
was there something specific on here that you wanted to? Yeah.
Well, it kind of just goes through like how it sort of how Go thinks of interfaces in particular, which made
Mm-hmm.
it interesting, and how sort of interfaces are like this concrete type and value, and then that's kind of like the basis primitive for sort of how everything else sort of builds off it. And so if you don't have much like sort of context for reflection, this is a great sort of like probably 10-minute read to get up to speed.
Yeah, and you mentioned interfaces, and that's actually a really big thing. I mean, it's sort of people talk about it in Go, and people use interfaces in Go, but I don't feel like people fully take advantage of interfaces as much as they could.
Mm-hmm.
There are a lot of times I'll use a library when I wish they had made an interface for something instead of made a concrete struct type,
Mm-hmm.
because that allows you to replace the implementation, wrap the original implementation, and then still use that object in systems that expect that interface. So
Mm-hmm.
there's a whole thing of programming to interfaces that sort of goes back, since the beginning of object-oriented programming, and Go really takes that to heart and does it really well. And COM is actually really encourages interface-based programming, and uses that for some of its extensibility stuff. But so most of the reflection we won't really get into. We'll just kind of use it in this example. And there's already kind of an example in here, but I'm going to start over. So I'm going to delete these. Did you look at the example that this sort of foo bar? It's very kind of,
I did, yeah.
yeah, kind of didn't really. There's sort of no meaning in just using foo bar and stuff like that to show the mechanics. So in this example, I actually want to build a simple web server, and then also And then also a component for an SSH server, so you can run both web server and SSH server in the same daemon, the same project. And then when we do plugins, we'll move SSH into a plugin. So the core application will just be the web service, but then if you have the plugin, it'll also be an SSH server. And so I think that would validate the plugin functionality, right?
Mm-hmm.
So if we were to pretend that this example directory was its own kind of application, its own repository, the command directory is sort of the conventional directory to put any kind of CLI binaries that your Go program is going to make.
Mm-hmm.
And we have a directory called example because by default, if you go build something, it uses the directory's name. And then our main entry point is main. And the idea, for the most part, is using this framework, you would use this component of it called daemon, which actually ties together some of the stuff that it provides into something that's designed for running daemons. Namely, like you want to have one or more concurrent services that are running while the daemon is running. And the source code, if you looked at it, is pretty simple. The daemon component is made up of initializers, services, and terminators. And these are all extension points, which is a concept, which is, and these are all interfaces. Two of them are defined here. So an initializer just says initialize daemon, terminator just says terminate daemon. Service is external, it's from another library. That interface is basically just start and stop. So if you were to implement a service like an HTTP server, you would build a start method on it that would start running it, and then a stop one that would shut it down, ideally cleanly. And this library suture is, I'm using it just because it has the interface, and then it has this kind of almost Erlang style process supervision for services, and for every service it will actually wrap it so that if a service panics, it'll capture that panic and basically just log it and then try and restart the service, which is a very kind of Erlang thing to do. And it's kind of a complicated, like we don't really use all of the functionality that it provides, so at some point I might replace this with an implementation and that service interface in here, but for now I'm using that library. So our main just calls run, and it sets up a component. Zap is the logging library. So right now there's kind of two. One of the things COM provides is an API for logging, and this is not really finalized, but it basically gives you a bunch of interfaces. A lot of the time you would just use logger, but if you're writing a library, for example, you probably just want the debug logger because you don't really want to log other stuff. You would want to return errors. And this interface is actually borrowed from the Zap library, which is made by Uber, and it's a really, it's probably one of the better recent, it's not even that recent now, logging libraries in the Go world. And it defined this interface, which is for every log level, which I have opinions about. For example, I don't really use warn or error ever. Something is either for developers in debug mode or for users in its info. Excuse me. And that's a different topic, but one of the nice things is key value pairs is sort of structured logging is kind of becoming this sort of standard way to do logging. But built-in logging stuff is just still like string oriented. And so what this library does is it has a, for every one of these, you get info, which is just like print.
I'm actually curious really quick.
Yeah.
Why is it key value pairs becoming popular?
Because so when you, most of the time logs are going to be sent to a central log aggregator. And as you know, it's like super important for debugging and in production and stuff like
Hmm.
that, finding problems and stuff like that. And traditionally, logs were like semi-structured. Like it's like, here's the Apache log format. This is what it looks like. Like here's the IP, and then here's the path that was used. And so
Hmm.
people came up with when basically we started building tooling to process logs and display them in a nice way, to show like analytics and statistics and like find problems like, oh, here's the HTTP error requests. But that meant processing the logs, which a lot of the time meant like doing a regular expression on
Hmm.
them.
Yeah.
And then every logging, like Apache just happened to be a common format. So a lot of other web servers would copy that format, but then
Hmm.
also have other formats or allow you to do custom formats. And then for every time you use a custom format, you then have to create a parser in order to use that for
Hmm.
anything important. So structured
This kind of
logging,
normalizes it.
yeah, structured logging is normalizing it in some way. A common way is JSON. So for every log entry, it's a JSON object, and you would have fields. One of them might be message, but then it also might have other context information like the user ID and the server that it came from, and
Mm.
all this stuff.
Hmm.
Some of that used to be modeled in the syslog packet structure, but just more and more like that kind of stuff is just modeled in the log message because it's structured logging, so you can kind of put any values in there. And the better tooling you have, the better you can just like put more data in there so that you can go back and process. And there's a lot of tools right now like Honeycomb that lets you do kind of real-time analytics and break things down to do real-time debugging of things. And it's all possible with structured logging. So traditionally, though, and most libraries don't do structured logging, but part of that is because the standard library doesn't have structured logging stuff. And so in some cases, you don't want to do structured logging. But this was the first API that sort of said, here's like your basic like info and warn that takes arbitrary objects, plus the printf style ones where you can do a template and then
Hmm.
provide arguments. And then the last one is, I think I've seen a couple others, but sort of the W or with, I think is what the W stands for, which is log your message and then provide a bunch of key value pairs. And this API is very simple in that it just expects the arguments to be every other be a key and a value. So you do your message and then a key and then a value and then a key and then a value, and you can just do arbitrary number of those, and then it'll process
Hmm.
those key values when it actually produces a log message and then does whatever with that. Um, so that's key value logging, and but logging in general is one of those things where you write a library that has logging, you're sort of coupling yourself to a logging library, which most often people will use standard logging, the standard log library, which of
Hmm.
course doesn't have structured logging, and maybe not, the rest of your app might not be using it. So it's very frustrating. And
Hmm.
a pattern that people would do is instead define your own logging interface and then log to that and then allow people to implement something that implements that interface. But if
Hmm.
every library does that, then you have to kind of.
Yeah.
So the idea here was to try and come up with a semi-standard, at least for the Calm ecosystem, logging API, and then you could back that with any kind of logging library. The Zap implementation, we don't have to do anything because the API is exactly the same. It's where I got the API from. The standard library doesn't have a lot of those methods, and it doesn't support key value stuff. So I had to do a little bit of wrapping to support that API with the standard logging. But now you can basically drop in either the standard logging or Zap, and
Nice.
your application can choose, and any components that are programmed to the interface will basically use whatever you've set it up to use. So logging now is a dependency for your components, or if it is, it's done in the same way that all other dependents are. So COM is also kind of a dependency injection framework. Um, so anyway, Daemon sets that up, and then it sets up the registry. You can create your own registries, but most of the time we use the default registry, which is just like an instance of the registry in the COM package. It sets up configuration, which a lot of this might be moved into a configuration package. Then this is kind of where you get the idea of how extension points work. Any component that implements this interface, which means implements this method, and is registered with the registry, gets added to this list of initializers, just magically. So this component just has to iterate over initializers and call that method, and it'll call it on any component that implemented it, allowing them to hook into this daemon lifecycle hook. And then similarly with terminate, we set up the signals to look for interrupt, and then we try and stop everything, and then we, anything that implements terminate daemon will call that as well. This is happening asynchronously in a Go routine. So after we set things up, we actually just call serve, which will call, actually it's serve and stop. The service interface is serve and stop. I said start and stop before. So it'll call serve on all the services. So you can just implement a component that says serve, and register it, and it will be started in this system. So
just to clarify, you would have to implement initialize and serve, and it could technically just automatically be seen and sort of started and used.
And in fact, you don't have to implement initialize. You can really just implement any interface independently. So we could, in fact, we'll do that now, is just implement just the service interface and create a little web server. Oops. So the COM also kind of implies a lot of conventions that we've developed, and so we kind of have to determine those as we go along. But one of them is, most often it's a one-to-one mapping with a package to a component. Because most of the time what a component represents is the functionality of a package. And Go idiomatically is sort of like, don't repeat yourself. If you're in a package called web, don't create like a struct or an object called web, because you read most things as package and then the type name. So here, if we define a component, then it's the web component. And it also makes it a little more clear that, oh, we're using components here. So we don't actually, we'll implement some fields in here later, but for now we'll just implement that service interface. Serve.
So on that component, you would define sort of the dependencies that would get injected from from the
and actually we can do that here. Instead of doing this, we can actually use the logger. So we'll create a log dependency here, which, what was it called? I guess just logger. So we want logger. Info. It imported the wrong thing. Log. Yep, there we go. So then once we define a component, we need to register it. And so one way you could do that is in your main, you could basically register them all. However, a common idiom, at least for when you're building your own components for an application, is to register them in the init function. So this is called in every package when Go loads a package, when it imports a package.
Oh, that's like that's something just inherent to Go. If you have an init function, it will just be loaded when that package is loaded.
Yep.
Oh, I didn't know that. Okay, good stuff.
This registration method is a little bit more verbose than previous versions, but I just haven't created a simpler version of it yet. So basically, we call register. We have to give it an object, a COM object, and so that is kind of a wrapper object, and then we specify the value, which is basically a new instance of component. So unlike, Go doesn't have like initializers, but there's sort of an idiomatic initializer, which is like, oh, you would do like new component as a function that returns a component, right?
Mm-hmm.
And that's maybe an initializer. In this case, with components, we don't really do that. We always create the instance. You could fill this out and create, if there's stuff in here, we'd fill that out.
Yeah.
But because most of the fields in here are going to be populated by COM, we don't do that. And any other kind of setup that you would do that via the daemon, initialize daemon.
I
Configuration will come to you in a bit, but if you had to do initialization, you could do that with the initialize daemon kind of callback. In fact, we can do that here just to kind of see. The one thing I have to do about serve, because serve expects to block. If it returns, then it's going to be like, oh, it stopped serving, something went wrong, and it'll restart it, and it'll just go in a loop. So this, because there's an error, that also gives us a chance to do any kind of like validation. And if there's a problem, we can return an error, and then it'll stop it from starting. But we'll just do another log. So this does everything. If this is imported, this is called, which will register this. And so all we have to do is import it. But because we're not using it, we do this, which will import it without giving it a name. Because if you have an import that you're not using, it'll give you a compile error. So this allows you to, this sort of like setting it to, because you can actually alias stuff when you import. And so this alias, this basically aliases it to, nothing. And this is most often used for what we're doing, which is a side effect import. And so it's actually not the best thing to do stuff in init, but it can be handy. If we were doing a reusable library, we might put that in a subpackage so that we can use web without having a side effect when we import it. But because this is our own application, we don't have to worry about that. App web. So we should be able to actually go build this. Example. Mm-mm. 17. Web 17. That's interesting. It seems like log was not set, and I guess that is because good zap. It's possible they changed the interface. I'm not sure. I'll switch this to the standard one because I know that works. 53. This is kind of odd because I've not run into this, even though I've kind of changed some stuff before. So, and I'm pretty sure that it's not caching or using a different version. Let me double check. Because sometimes I'll have multiple versions of a project in my Go path, and we'll use a different one. Like automatically import the wrong one. Oh, no, I'm stupid. I didn't actually set this up to get the injection.
Oh, do you have to call singleton?
Yeah. So this is, you know, to be more explicit, whenever you have something that you want it to populate, you say whether it's an extension point or a singleton. That should solve it. I won't do that.
Nice.
So it called initialize, then it called serving. If we had any other components that were registered that implemented any of those, they would also be called there. And actually, not in a random order, but actually the order that they were imported, which is kind of nice. It gives you some control over the order of the calls. Most of the time, it shouldn't matter. Like if you make something that it does matter, you might want to reconsider or, you know, change how that extension point is used. But so far, so good. I guess we'll do a HTTP server and set that up in initialize.
So any component that you're sort of leveraging from the com package, from the registry, you'd have to add the struct tag com singleton or ext point.
Yeah. Which is kind of funny because I didn't remember to do that, but it's kind of just being more explicit, and then it sort of self-documents as well. So once you see that, you're like, oh, this is going to be populated by com, as opposed to expecting it to be set internally or by something else. This is not what I wanted. Setting up a server this way, a lot of the time we'll use one of the helper things like listen and serve, but I wanted to do things this way. So c.server.
Oh, I see. Okay.
And then actually I'll make the handler the component, and then we can just implement a serve HTTP method here that takes this. So oh, bytes. It's going to listen on 80, 80. I'm going to do
serve HTTP, right? You have server.
Correct. Thank you. That is the point of pair programming. Listen and serve. which I guess we'll just see. Oops, log info error. I'm going to hard code this there, and yeah, this should work. Nope. Yeah, 21, we don't need to do this. I'm going to start doing go run. So we should be able to kernel localhost 8080 hello world.
Woo!
You'll notice if I get rid of these, we don't get any logs because out of the box the built-in HTTP server doesn't do any logging. But we'll worry about that at a different time. So we did it. We could go a little bit further with configuration, or we could do the SSH server so that we can get to the plugin stuff. What do you want to do?
Let's do the configuration stuff because I think it kind of like wraps up like how you can sort of configure these components, and it seems like a really sort of like a complete example.
Mm-hmm. Okay, so config is also pretty simple. Again, defined by an interface. We have this interface called settings, which is pretty much just used by this callback. So if you, as a component, if you implement this interface, a config initializer, which we'll do here, then we get what it passes us is an instance of
that's awesome.
settings, but it'll already be set up for the namespace for this component, which we'll see in a bit. So we can, or I'll do that here. So we can say, here's this is TOML, and so this is sort of a top-level key called web, and then we can basically do arbitrary values in here. We'll do listen adder equals 8,000. So our goal is to get it to listen on 8,000 via this configuration. So again, Damon set this up, basically sets up conventions for how to look up that file and all this stuff. I think that'll be moved into config, so it won't just provide an API. And then most of the configuration loading is actually done by Viper, which is a great Golang configuration system that can support TOML, YAML, JSON. So it's really nice because you can actually just choose what configuration format you want and use it. And again, this API is borrowed from Viper. Most of it is directly just Viper's API. But again, Viper doesn't provide that interface, which is annoying. So here we provide that interface, because anytime you have like something like that, you have to do a typed way of getting values. So you usually have getters for every type. So so Viper does most of the heavy lifting, but we could in our initialize config, we could use settings and get each value independently. That's kind of how the old version used to work. But because we have this, almost all the time we end up using load, which will basically deserialize the configuration into a struct. And so that means that most of the time, all you need to do is config load and pass it something that you want to load the configuration into. So in some cases, you could just load it into your component, and so it's going to basically try and load any of the fields that it has into struct fields. So if we were to do, adder, which is a string, and then internally it's using map structure, I think. And so this lets us define the name that it will kind of map to.
I didn't know about that map structure struct tag. That's cool.
Well, yeah, it's part of a library called map structure. And map structure.
Oh, I see.
So
Okay.
there's something similar exists for JSON, which is standard library.
Yeah.
Map structure is one that is for a slightly different scenario that's kind of implementation specific to Viper, but more or less is just saying like once you have a structure of like potentially maps or a struct and you want to load it into this one will help you map the names. This struct tag lets you do that. So in theory, we can do this. If I recall, this is how this works. And we'll even add ... after that. So this should work. Should listen on. It needs a return. In case you have, well, actually, because load returns an error, we'll just do that. Listening on 8,000.
Boom.
Because it was configured from this configuration file. And just to prove it,
nice.
So, but one thing is that a lot of the time you might not want to use the same struct as the rest of your component for configuration. In practice, maybe it's fine. I haven't quite figured out whether this is, kind of convention or not. But one thing that you can do is create a separate config struct. And you could either, through composition, have a config object here, or you could use embedded structs. So sort of like inheritance, but it's not really. But if we were to say config, now a component has all the fields of config. And then to be explicit about that, we can point to, it's basically kind of an interesting hack where it is composition, where if you embed a type within a type inside a struct, it is a field by the name of the type, so config. And so you can reference it internally as if you had like a config field, but also any of the attributes, any of the fields are also on component unless they're overwritten.
Oh, so you'd still call cadder instead of cconfig adder.
So in theory, this will still work. The nice thing about this, though, that is that when we do go docs, this struct will be very explicit, like this is the configuration for this component, and then you can have comments for this, and so you'd know where to go to read about configuration. You won't have to define that somewhere else. It'll just be part of the component's go docs. So this should work just as well.
Nice.
Okay, so now we're going to do an SSH server, and then we'll do that into a plugin. How are you on time? Do you have?
I'm all good.
Okay. And if anybody is watching and you have questions, feel free. I mean, this is kind of a last minute out of nowhere thing. It's more an experiment with Screen Hero, but I'm actually really glad to get all of this kind of documented while also hopefully getting plugins done. So it's a win regardless. What about you? Do you have questions?
Not really. This is actually super helpful in sort of adding context to the code. Because if you just read it, sometimes it's not quite as clear. But in this example, I'm like, oh, it's incredibly clear and straightforward, and it's It's really useful.
You can almost reuse the same code because the Glider Labs SSH library has a very similar API to the web one. And we can even use this as well. We just have to set this up a little bit differently. Although I'm going to have to look at the docs for that. So it is pretty much exactly the same. Handler. I'll even do the same thing and make the handler method on the component. Which is just takes an SSH session. I guess we name it though, so we'll just handle, because it takes a function instead of an object that implements an interface, at least for the moment. Session. Which is an interface. And basically, actually could do the same thing. And actually, I think that's all I needed to do. In theory, you wouldn't have to write these. I actually have some components for SSH and web, but it's hard to come up with a good example to do that isn't like pointless keywords, like something that has meaning. So, and if I were to use those existing ones, it would be kind of like complicated to see what's going on. We'll listen on 2222. Yeah. So one of the things is, because we haven't configured it otherwise, it's going to generate a new key every time. So we'll have to clear the way SSH works is it stores the host key whenever you connect to a server, and then checks next time you connect if the host key is the same for that IP and port. Since we're not specifying one, I guess we could specify one just to avoid that. I'll point it to my user private key just for fun. This is set option hard coding it. So I'm using my SSH private key as the host key because they're the same thing. What else? That's it. I think we can, we haven't initialized this. Add this to here, side effect import it. Now there's an SSH server, or we'll try the web one first. And SSH, I'll get rid of the key just in case, because I'm sure there's a key associated with this. Oops. R removes the host key.
Nice.
Hello world. There's no new line. Now let's add a new line to both of these.
And with the plugin system, it'll be like even easier. You won't have to do the side effect importing, right? You'll just basically upload that shared object file to some folder or something.
That's the ideal. Yeah. So I guess we can do that now. So we'll create a plugins package that will kind of set up how plugins are loaded. Then we'll modify daemon to have to load any, to basically use the package, load any plugins.
Mm-hmm.
And eventually that code might be added to the plugin just to simplify daemon and put more convention into the packages. And then we will compile our example app without SSH and then separately compile SSH as a plugin and then try and get them to run together. And if that works, then we've succeeded. And I've never done this before, so nor do I really know how it would be designed. So I guess we'll start with the docs. Okay, so we're going to have to do an example plugin as well. I guess we'll do it this way. In our example plugins directory, we'll do an SSH plugin.
Mm-hmm.
And then that's what we would compile as a plugin. And we'll put all those shared objects just in the root of plugins.
Mm-hmm.
And then the way I want to design this is that the daemon would, in the same way that you can actually point to configuration with an environment variable. So the fact that we name this daemon example, you can actually point to a config by saying example underscore config to point to a configuration that's not in the same directory. And so similarly, we'll have example underscore plugins to point to a directory while it will look for plugins to load. Which is, again, something that is not done here. We'll have to do that ourselves. So using this, you always have to set up a little bit of like infrastructure and conventions and how it's used. Hopefully after we write this, you won't have to even do that. You can just write components and it will work. So package SSH, even though it's not the same thing as a handful of packages called SSH, but ultimately the full path of the package is the package name. So we'll define maybe just a variable called hello world that contains hello world, and then we'll try and load that up just to try and get this all working, right?
Oh, just a heads up. The plugin system only works on Linux, so we'll probably have to put it in a Docker container to test it.
Good call. That'll be pretty easy. Let's see. I'm trying to think what I want to do. because I know I want to compile this as a plugin and then try and use it immediately. So maybe we'll come back to the plugins package and just kind of work in main and just try and get it to work between these two. So basically, instead of, maybe I'll just comment all this out for now. Create a new func main. It's one of the weird built-ins that the Go has, which oddly,
yeah, that is unusual.
Oddly, it does not go to standard out. It goes to standard error.
Nice.
And then we'll do a Docker thing to new file. So that we can run this. We'll use the Golang. Okay, we need 1.9. I think we can just do this. And then the work directory. Let me find another project that I did this in. Let's see, what was that last thing I was working on? Not command. I want to do the, well, I guess I don't need to do that. I really just need any example because I don't remember anything. I just like copy examples from previous times that I figured it out. This might not even be good enough. This doesn't do what I want, but maybe it's enough to.
What do you need it to do beyond, I guess, adding the files in and then setting a work dir?
It's just like how, you know.
Oh, the pattern. Yeah.
Like this. Excuse me. This image has a go path set and /go. I'm pretty sure, and then we want to copy stuff into this directory. But because this is actually, I'm going to have to put this in the root for it to work because it's not going to be able to import stuff that's in a parent directory. So it'll just be that, and then we can do copy that into the current directory. And then run go build example, command example, and we'll put the output in root example, and then we'll do an entry point of example. So this should build it and then give us a container that if we run, it will say hello. And then that'll be a good start. I killed Docker though because it was running. Thought it was consuming too much memory. Well, while that's loading,
so real quick, talking about building plugins, which would essentially be components. Would you essentially just take largely what you already wrote as your component and just pretty much dump it in there, and then just compile it with the plugin mode or the plugin flag when you do go build, I guess?
pretty much.
Okay.
The only thing is the registration will have to be a little different. I'm pretty sure. What did I tell it to do? I don't know what's going on. Oh, I tried to print. Okay, hit the wrong button. Docker's starting. Almost. Okay. What do we all call it? Just call it example. What? Where does it think I am? Oh, I'm in the wrong directory. Oh, I don't have that. There's an Alpine variation I should have used. This would have been faster.
Is it just Alpine dash 1.9, I think?
I think it's 19-Alpine. Basically. But we've already gone down this path. Let's wait for it. Oh, no, it has like, oh, this is it's like Office Space when he's like trying to.
This is actually like extremely cool though, because I could see how once you start to develop like just like a dozen of these components, you could start to do like some really cool stuff. Similar to like how you can describe like a whole sort of application with Docker Compose or something, and you can kind of think at that level of your app. It's kind of like that in a similar-ish way where you kind of think about your level at that, or your program at that level.
Yeah, it's interesting how, and I think, I'm pretty sure it's true, and it's probably going to take people actually using it to be convinced of this, but these primitives, these mechanics that I've put into this, COM system, I think actually makes code much more reusable.
Mm-hmm.
And so if you increase the reusability and some other properties of, functions of code, then, within that ecosystem, there's a lot less code you have to write, and you can start more quickly building the thing that you actually want to build, or like you said, think at a kind of higher level. I mean, in the same way, it's even though it's not the same as, oh, I didn't like that. I think as I need to do this. Kind of like React components. Oh, I didn't like this either. So the current directory, example, and example. Because I should be in this directory. This should work from here as well. Permission denied. Oh, because I want to write it to there. Well, in the container, it's root, so. That's probably the problem. Well, no, maybe not. Okay, we'll call it something else. See, it works here. So what am I missing here? Oh, I guess it's just like it's trying to run this as a program. It's supposed to interpret it as a fucking shell thing, but it's not for some reason. I need to wrap every argument in a thing, I guess. I didn't have to do that before. But I guess to make sure that that's the problem, I'll just do it.
Does it have anything to do with example, the output not using a dot for a relative?
The output. Oh no, well I want to put it in the root. And in this container I should be able to because it's being run as root, so whoops, that's not what I wanted. Oh, I didn't close that. See, now it works.
Woo!
That's weird. I don't know why that changed. Maybe, see what? How do you comment stuff in Docker files?
Maybe, I think it is hash. Yeah.
See, maybe if I didn't do the quotes, then it would be okay with it. I might be confusing some of the syntax.
Oh, I think that is it. I actually don't use quotes when I do a run.
So it's a weird thing because it's more convenient to just do some shell stuff, but you don't always want to do shell stuff, and so they made it so that you could just have it exec directly what you want to run, but then it needs to be able to interpret, it's not going to actually parse this as a shell command like you were running it on the command line. So you need to actually give it a structured thing that's like the first thing is a path to a binary or a binary in your path, and then the rest are arguments. So I guess their parser is just like, oh, if it's a string, then like you're trying to do it structured with one argument. So, and I usually do entry points as command this way because I usually don't want it to run under a shell. Because what it'll do is it's basically saying it's going to run bin sh and then take what you put here as the argument to it. So it's running it through a shell. And so then whatever you're running would be run under a shell process, and it's like, well, why do I need that extra process running there? So, so now I could run it, docker run example. Hello. Okay, so we've got our workflow. And we want to compile this as a plugin. So why don't we just try and compile this as a plugin? Which will basically be this.
Woo!
I guess we'll just put it into like the same build mode plugin. The output we'll call it. We'll put it in SSH with, I guess, .so. But here we say example plugins SSH. So we won't use it, but hopefully this should compile it. That seemed to work. So now we should be able to use the built-in plugin package and load it.
Mm-hmm.
Basically this. So we'll do hello and then we'll load it. Hard-coded to ssh.so. Yep, we'll panic. We get
We want to look up hello world.
Variable called hello world, and then that'll be an interface. So then we will cast it to a string. Although we could also just do format print line, which should just give it to us. Hello from app, and then hello world would be coming from our plugin.
Nice.
Ooh, invalid elf header.
Let me.
Are you Googling this too?
Yeah. With non-main package.
Oh. So maybe I needed to
How
call
precisely?
it main. I mean, that's fine. I can not call it main. Is that, do you think, the issue? Or not call
according
it SSH,
to
we'll just call it main.
Someone with 2 thumbs up. Yeah, pretty much.
Main not defined, undefined main. So if we call it main, we now need to have a main. Which, what, did they have a suggestion for what to...
He says if you use build mode plugin, but you don't build a main package, you get an object that can go into a plugin, but you don't get an actual plugin.
What?
Again, that is a meaningful thing to do, but can be confusing. Maybe it's not runnable, even though it's a package.
Okay, I guess that's fine. We can have a main, but I guess it just does nothing, and then that's fine. So I did that.
Oh, I see. The overall system relies on having a main package to run the imports.
Ooh. Yeah, okay, it has a pointer. I need to dereference it, I guess. But it doesn't, yeah. Fuck. Alright, how do we do anything with this? V and F.
You do a type assertion?
Type assertion. Okay, that's fine. That's weird. Pointer, cast it to a pointer to an int.
Yeah.
In this case, a string, so. Oh, it doesn't like that.
Is it because a string is already a pointer? I feel like I heard that regarding Go and its internals.
I don't think so. I believe it would be an array that you might be thinking of. But maybe it's string. I just don't understand this because I don't think it cares about this string stuff. It's like, it doesn't like this. Okay, well, how about this? Or this.
Mm-hmm.
It's probably what I want. Nope.
Oh, shit.
I see you.
Sorry.
Does
I guess do non-pointer, right? Because it did print out the memory location.
oh, that's right.
Mm.
It
Mm.
is so it's like I need to do this and then do this. I mean, we won't have to do this when we have like an object that we're referencing, but like I just wanted to get to print this damn string. So
I have a
because
question. So when we do the type assertion, isn't it just returning like a reflect value? So then at this point, we would actually want to call like dot value or to turn it back into the value.
is that true?
I don't know. Let me see.
Lookin gives us a symbol, uh, which is it's something special. I don't believe it's a reflect value. It's at least the type that we work with is part of the plugin package. There we go. So it's kind of just a special case. It's not actually like a reflect.
Okay.
So this worked. We did it. We loaded a plugin. It's the first Go plugin I've ever loaded. So now we need to kind of iterate from here. Let's see, we could just jump into copy and pasting SSH.
Mm-hmm.
Yeah, let's do that.
And then write the stuff to parse the plugin folder.
Well, first we'll have to, I think we have to get rid of a init. I don't know how this works. Like if a init's going to be initialized in the like a in the namespace of the
Oh, I see.
built-in packages for the plugin, so it won't actually be the same registry. Like I've run into this problem before. So to kind of avoid that, we won't do it on init. I also have to have the main function, but we'll create like maybe a register function, or like a not register, but like something to just give us the component, and then we can register it ourselves. What would we call this?
Get.
Yeah.
Do. Yeah.
Foobar. I guess we'll just do this and we can rename it later. So I'm going to so now instead we're going to look up get,
Okay.
which is a function, and just to hopefully it type maybe, because I was going to say if I have to reference the package, then that means that I have to compile with the plugin. This defeats the whole purpose. So I think this has to just be an interface, an empty interface. Which means I think this has to be an empty interface as well. So type is plugin. I don't know what to call this. Getter. Funk. Yeah. So you can it's not exactly a type alias, but you can do this and it will let you cast to that, or type assert to getter, but it's this now, getter, and then the component getter, we'll call it, which normally we would register, but for now let's try and like, oh, I can't program to it without knowing what it is. Maybe we'll do some reflection and just like get the type or something.
Oh yeah, do type of.
Yeah. Type of, I think we just have to do that.
And obj.
Yeah.
Obj. And then hopefully that should return component or star component, right?
So
Expected get.
Okay. I doesn't like this. Oh, it doesn't. Just doesn't. Yeah, it doesn't like the name.
Couldn't it just be in? Oh, yeah.
Okay, and then make sure this is right. Sure. We're gonna have to do some go gets, I think, or at least one go get for this, because the container won't have that. And then, yeah, that should be it. Seems like so much more work to build a plugin. like it takes a bit longer. I wonder what it's doing. Here we go. Of course.
Not main getter. We have to, oh, you already did an assertion.
I guess it just doesn't like that it is not that. So I'll just type asserted to this. Because it really isn't the same type, and I feel like sometimes it's not picky about that with functions. You can do type aliases now, and I think that would work. But I won't bother with that. Just do this. Maybe part of it is that because we're running it in a container and it's rebuilding the layer that would produce the compiled other packages. Basically, normally you have fast builds because it caches. Like if you import as the SSH library and it already compiled that, it would just use that. And so because we're doing it in a container, we don't have that, so I have to do it all over again.
Woo!
Ooh. Well, that is correct. So, though it's kind of frustrating that it's a main component because it doesn't really tell us, like, com is going to try and do, like, for example, config in com is based on the package name, you know? So it's like if I wanted to configure this now, I'd have to call it main, but like there's going to be a bunch of plugins called main, so I'm not sure. You know, in theory, we could actually have main and then have another subpackage or something in here that is called SSH, but we'll get to that in a bit. Let's just try and get this like actually registered. Which means I think we can get back to our old code in here. I see you. But we'll do all of this up front before starting the daemon, and later we can move it into the thing. We'll comment out SSH. I'm gonna, oh, this is not going to be there. It's in a container. I'll comment that out. It'll generate a new one. And I'm going to have it log plugin component initialized as our way of seeing that it worked, besides an SSH server running. Ooh, we're getting close. And so now we have to register it. Object. Whoops. That's it. Yes. I think that's all we need to do. How are you on time? We'll probably try and wrap up before the end of the hour.
Okay, that would be that'd be perfect.
Here's some things that we have to go get. And we're using standard logging, I think. Are we using the standard one? Daemon. Yeah, okay, so I think that's it.
And when we run this, it should run the new SSH plugin component, essentially.
Mm-hmm.
Nice.
And the web server.
Why not? I kind of like the idea of sort of thinking of like this ecosystem where everything sort of does one thing. Like you have one web server that kind of does one thing. Is that how you're sort of envisioning how the components will work, essentially? Or will you possibly add like multiple handlers to one component?
Well, like we already have a web component that basically wraps, some common things, ways you would configure a web server, and some things that we needed for command IO. And then it exposes some hooks that lets you add handlers to it and some other stuff. And even some other things like, oh, you're rendering templates, like here's a callback that lets you add new template functions in your templates. So you can have components actually contribute to the functions that you can call inside templates. And so I imagine that web component that I'm making being a web component that you could use. It'll be simple enough that you could use it, and if it doesn't work the way you want, you could copy it and just have your own. Or if it doesn't do what you need to do, but it's just like one thing, like can you build an extension point that would allow you to add that functionality to it? So this gets into, if you make it easy for components to be extendable, it allows them to be very simple and still meet people's requirements. And so hopefully that would avoid like the bloat that comes with a lot of things. Because it can either be a separate component that works with this component, it could be a special custom component that you wrote, or something like that, or just like a one-off, like, or it's simple enough that you can just copy and paste the code. But I don't know how some components will be that simple, but we'll see. Okay, I'm gonna run it and we'll see if it starts SSH. Oh, we don't have a config file. We gotta copy that in. And we have
That
to
was
call.
promising, though.
Yeah, it didn't crash.
Does that need to? I guess
This
so.
is weird. I don't know if this will work. Like main is special, and even though it's registered as main, it's like I don't know. Is this gonna work? But yeah, I need to copy this file. Copy. It's example command example toml 2 example toml in the root.
I have a feeling we're making an example.
It's like the John Malkovich of example. Example. This, of course, invalidated the cache of those go-gets, although I don't know if it cached those. I don't entirely know how Docker decides that it's not okay to cache something. I mean, obviously, if you do something that is not cacheable, then everything after will not be cached. I guess that's a good if you copy files in, it's never going to cache that, and then anything after that, it's not going to be able to cache because the output could be different.
Mm-hmm.
So maybe I should do these go runs before copying. These go gets, I mean. For next time. And I don't actually expect to use Go plugins that much, especially because most of the stuff that I make is in containers, and containers don't, like, it's not really made very well for like adding a new, because it's like a predefined thing. It does let you, if you can like customize a container, like a lot of people would customize some of the containers that I made, and it's just like they say from registry or logspout or whatever, and then they drop in a plugin. Like, that's kind of cool. But it's really good for like command line tools. Like if I build any command line tool, which of course wouldn't use the daemon package, but you can still do component-oriented stuff. It could look in your home directory for the plugins directory for that tool, and then load in any new things that would add new commands to it and stuff like that. So that'll be really cool. After all that time, it better work.
Moment of truth.
What? Oh, what? Not found in. Oh, because the working directory? Okay. Even though it's running this, it's in this directory.
Oh, I see.
And that's where it's going to look for it. So I guess I do want to put it in the current directory. So now I have to wait all over again and hope I did the right thing. Did you see? I did see that Doom documentary, the Doom music
Oh,
stuff.
yeah. You kind of had the same reaction I did. Like the first 10 minutes, I was like, oh, God.
Oh, God, this
But
guy.
then it gets, yeah, exactly. But then it gets like really interesting. I actually was toying around with his idea of that array as well.
I feel like it's funny because if you, in the question, someone was like, hey, I want to try that array. He was like asking for permission. Is it okay if I copy you and do some experiments with that array idea? I mean, I didn't do it as full. Like, I didn't do the side chaining stuff, which I think is where like a lot of the magic probably comes from. But just having that kind of huge array of different kinds of, ultimately just distortions, was a fun thing to do.
I don't know. Have you tried Isotope Trash?
No, I've seen it.
Oh, it's super, super good. You should definitely check it out. You can get really, really creative sort of distortions.
It's funny because it's sort of like I kind of stopped caring about distortions because I have most of the distortion is like guitar distortion, and I have an X effect, so it's like I've got all the guitar distortion I need. But there are, like, it is pretty cool to be able to, like, doing that sine wave thing, like the attack that you get. Like, it was almost, if you saw some of his examples where he's playing a really low sine wave note, and like the result actually sounds like a kick drum, like boom, boom, but also distorted. It like works as a very percussive thing. So yeah, I can see the value in having that kind of exploring other kinds of distortions for that sort of thing.
Mm-hmm.
I mean, I already have like you can do a lot of stuff with compressors, and some of the compressor plugins I have can get you some pretty crazy distortion. My chair's falling apart.
I do like his approach. Kind of made me think more of composition as like composition as a pipeline or something, you know, rather than focusing on like, okay, I'm using these chords, I'm using these harmonies or whatever. It was more about like the process
Yeah.
itself because he, you know, he all he put into it was like the simplest sort of sound, the sine wave.
I mean, I was kind of annoyed also by the fact that he sort of he made it sound like he was on board with them. I mean, I'm sure he understood that they're like no guitars, and then
Mm-hmm.
ultimately he just like, I mean, he even admitted he like once I put in a little bit of guitar, I just kept on putting more and more guitar, and that was my Trojan. I'm like, so you wanted to put guitar in the whole time? Because it sounded like, you know, but it makes like he's a guitarist, and it's just funny that like after everything he said in terms of like, change the process, change the outcome, but
Yeah.
after he did this crazy Doom array instrument, like he basically just went back to his normal process of like, crazy guitar and all that.
Mm-hmm. Heavy metal.
Oh shit.
Oh shit. Dang. Sweet.
That's super cool. Well, I'm
I have
done.
a question. Yeah. How did oh, never mind. Never
What?
mind.
What?
Oh.
What? What?
Oh, I was just curious about how web still worked, but it makes sense because everything's being registered with the same registry and web is being
Yeah.
registered under web
Imported here.
package.
So when you
Got it.
build the main app, it's building in web.
So the one thing to kind of fix or look into a solution moving forward is trying to still keep plugins in a package, like adding some sort
Yeah.
of abstraction around
That.
that.
Yeah.
Yeah.
Which might just be putting it in a separate package than the entry point that you load
Mm-hmm.
or whatever. Um, and then also basically this part here that I'm doing in main, this is the sort of thing that should be in the plugins
Would be in,
package.
in get or whatever. Okay. Yeah.
And then instead of hard coding open SSH.so, it'd be like look in this directory and go through all the files and see if, try and open them all.
Mm-hmm.
Or open all the ones that end in SO. I'm not sure the best way to do that. Or I guess with execute bit or something like that. And then have daemon orchestrate the plugins package. So main comes back to
Mm-hmm.
the simple daemon run.
Yeah.
And then, I mean, that's it at that point.
Nice.
Might change like the sort of expected interface for how you do this.
Yeah.
Like maybe this is called something else.
Could you actually just rather than calling a function, couldn't you just reference the component itself? Is that
And then
possible?
create an instance of it? I guess so. Although it's nice to, in the rare case that it needs to be initialized with certain
Ah,
values, it would be
yeah.
nice for the
The moment.
package to be able to do that. So this
Mm-hmm.
is sort of like, it makes a little bit more sense to provide kind of a factory method. Um,
Mm-hmm.
yeah, interesting. All that other stuff is pretty straightforward. So I might
Mm-hmm.
also, because I usually only do hour-long streams, and this is almost 2 hours, but
Oh, okay.
I'm pretty happy because we proved that it worked, and so then I can just fix some of those problems, which I think are pretty straightforward.
Yeah.
Maybe after a break, or maybe another day, because I'm not super. I don't need plugins for anything just yet. Again, because like command IO and all that stuff is just like compiling a server, but
Mm-hmm.
it'll be really nice to have when I get to command line stuff or when other people are using COM. Like it's sort of a great selling point. It's like, hey, here's a framework and it lets you build these cool components, and
Mm-hmm.
it sort of makes it trivial to build plugins. Like if you just build a component package and then build it as a plugin, it just drop in works with whatever apps you're using. Not that
Yeah.
it was that hard to do this plugin stuff, but it sort of like gives it a little bit more structure. Um,
Well, also, doesn't this lead to like you can actually just dynamically load things? So you could like not stop that server and just load new components and stuff.
Ooh, yeah, in theory, there's some kind of lifecycle stuff with configuration
Oh, I see.
and all that.
Oh, that's right. Yeah.
But it is something that I want to get to at some point because I want to be able to do network plugins and not necessarily to run on another machine, but actually to run another process. Because that's how a lot of people did plugins in Go before this plugin shared object system. You would just say like, I'm going to create another binary, and then it'll talk over the network using RPC.
Oh, okay.
And I still think that has some benefits. One of which being like you can create a plugin in any language, right? As long as you can speak the RPC. And I'd like to support that model. There are things I want to build with that as well. So at some point, I have to think about what happens when objects are registered later after start, as well as disappearing. But I think that might be like a V2 thing for this pass of the framework.
This is super cool though. Good shit.
Yeah, thanks for coming along for the ride, and anybody else that came in to watch. And if anybody is watching this afterwards, you made it to the end. So
Woo!
I guess that's
Okay.
it.
Cool, man.
Yeah, I guess I'll talk to you later.
Okay. Later, man.
All right, bye.